All right, so today we want to talk about differentiation. Differentiation. There's a new topic that was brought in the commerce. Um, is really treating in native class, but it's a new thing brought in the commerce. We want to look at it. All right, so let's dive straight into it. Okay, so in coordinate geometry one, okay, which we have created already, we said the gradient is a change in y, change in x. Is a y2 minus a y1, x2 minus the x1. Okay. We also saw that the gradient of only 2 points on a straight line, the gradient of any 2 points on a straight line, okay, gives the same result. The gradient of any 2 points on a straight line gives the same result. But for a curve, when you're dealing with a curve, the gradient on any 2 points does not give the same answer. So for a curve, it does not give the same answer. Okay, it's not equal to the same answer. This is for a curve. And so the process of finding the gradient, of a curve, okay, on the curve is called the differentiation. That's what differentiation comes in. So for a straight line, the gradient of any 2 points on a straight line gives the same result. But for a curve, it does not give the same answer. And so the process of finding the gradient of the curve of a point on the curve is the differentiation. And so for the differentiation, we have y is equal to say x raised to the power n, any power. The differentiation formula and differentiate y with respect to the x. This n will come and multiply the x, okay, and the power minus 1. So this gives you the differentiation formula. This is what we need. So now, if I, for example, I know y is equal to x squared, I say it should find dy dx. Dy dx is equal to this 2 will come and multiply, this 2 will come and multiply the x, we have 2x, and the power is 3 minus 1. And we all know 3 minus 1 is 1. Then we do x. And then y is equal to 4x squared, 4x cubed. I want to find dy dx. Means that this 3 will come and multiply the 4. We need 12. Right? And the power, which is 3 minus 1. That gives me. So basically, this is how differentiation is. Then we go in depth to it. So follow me as we journey through differentiation. It is very simple and it's applicable everywhere as far as mathematics is concerned. Follow me as we go. You need to also understand, for example, if I give you y is equal to say x to the power 4, and divide dx with the whole multiply dx, the power minus 1 is 3. Okay? So, what if I give you a constant? If I give you a constant, say 3, so if this y is a constant, say y is equal to 3, the curve is a straight line. So, okay, this y is equal to 3 is a curve. It's a straight line. Parallel to the x-axis. Because it's parallel to the x-axis, the gradient is always 0. So dy dx will be 0. in effect, what it means is if you have a constant, taken, the y dx is always zero. Anytime you differentiate a constant, you get zero. If you have y is equal to 1,000, the y dx will be equal to zero. Anytime you differentiate a constant, it's zero. Why? Let's see. For example, y is equal to 10. It means that y is equal to having 10, x raised to the power 0. And x raised to the power 0 is 1. 1 times 10 is 10. If I want to differentiate, this simply means that this 0 is going to multiply this 10 to have 0. Right? And 0 minus 1. Which anytime anything in the power, right, and 0 produces 0. That's why we differentiate constants with 0. Alright. Let's move on to maybe deeper level. So differentiate. Let's some examples. Example. Differentiate. Differentiate the following. Differentiate the following with respect to x. First one is 2x minus 3. The second one, 3 over x to the power 4. Third one, 2x5. So let's solve the solution. If I have y is equal to 2x to the power minus 3, we find the y dx. So the y dx equal to negative 3 multiplied 2, give you negative 6. And you bring your x in the power minus 1, so minus 3 minus 1. That will be negative 4. This is now minus 6. It's 4. Because we have x raised to the power minus 4. Take this minus as 1 over 5 plus to the power 4. And 4 so now we move on to the second example. Second example says that y is equal to 3 on x raised to the power 4. This y on 3 on raised to the power 4. Right. So this 3 over x raised to the power 4 is the same as 3x negative 4. Okay, so differentiating it will mean that negative 4 multiply x, will multiply the 3, making negative 12 and x. Negative 4, okay, minus 1 gives me negative 5. So it's my negative 12 on x raised to the power 5. Okay, so let's solve the third one. If I have y equal to 2x raised to the power 5, this simply means that when I differentiate, I'm going to have 5 times 2 making 10, x, the power minus 1, which is 5 minus 1, and 5 minus 1 gives you 4. So this is basically how differentiation is very, very simple. If you have y is equal to 4x4 plus 3x3 plus 10x plus 5, not difficult at all. 4 times 4 gives you 16x, the power minus 1, 3. 3 times 3 gives you 9, the power minus 1, 2. This one is having 1 here, so 1 times 10 is 10. The power minus 1, so making x raised to the power 0, which is the same as 1. So 10, and if you differentiate a constant, you get 0. So this is the final answer. So that's it. Okay. So see you